Several stall tests were conducted to define the aircraft's minimum in-flight airspeeds and their variation with respect to weight, altitude, and various aircraft configurations. As the buffeting in the airframe communicates a stall warning in these low-speed, high angle of attack regimes, the pilot demonstrates the aircraft's excellent handling qualities through the stall and recovery. All the stall speeds demonstrated by the MD-11 met or exceeded the predicted results.
McDonnell Douglas promised the world the modern, fuel-efficient wide-body jet, the MD-11. Safer than its predecessor, more advanced, built with lessons learned from the DC-10, an aircraft that had earned the nickname Death Cruiser after a string of catastrophic accidents. But less than a year after entering service, one went down, then another, and another. By the time Boeing ended production in 2000, the MD-11 had suffered 10 hull loss accidents, resulting in over 244 fatalities across global commercial service. Pilots called it unforgiving. Investigators found a pattern. And on November 4, 2025, another MD-11 went down in Louisville, Kentucky, in what became the deadliest UPS Airlines accident in company history, killing all 3 crew members and at least 11 people on the ground, a total of 14 fatalities. This is the story of an aircraft born from tragedy, designed with fatal compromises, and cursed by the very features that were supposed to make it better. To understand the MD-11, you have to go back to its predecessor. The DC-10 was a commercial disaster wrapped in engineering failure. In 1972, an American Airlines DC-10 nearly fell out of the sky over Windsor, Ontario, when its cargo door blew open at altitude. The aircraft survived, but the writing was on the wall. 2 years later, Turkish Airlines wasn't so lucky. On March 3, 1974, a cargo door failure killed 346 people when Flight 981 crashed near Paris. Following the crash, the FAA eventually issued an airworthiness directive mandating modifications, but the regulatory response was delayed compared to what the NTSB had initially recommended. McDonnell Douglas hadn't even informed the FAA about cargo door problems during early operations. The information only came to light after Windsor. By the 1980s, the company was hemorrhaging money. The Long Beach facility reported significant operating losses, and 8,000 jobs were cut as development costs from earlier programs drained reserves. The company needed a successor to the DC-10, but they couldn't afford to design one from scratch. When McDonnell Douglas launched the MD-11 program in 1986, management made a decision that would seal the aircraft's fate. No new wing design. Too expensive. Instead, they'd stretch the DC-10's fuselage, add more efficient engines, and rely on aerodynamic tweaks. But there was a problem. Stretching the fuselage meant the tail had to work harder to maintain stability. The solution? They didn't make it bigger, they made it smaller. The horizontal stabilizer was reduced by approximately 30% compared to the DC-10, from roughly 1,300 square feet to 920 square feet. The goal was to save approximately 2 to 3% in fuel consumption, a modest efficiency gain that would create catastrophic structural vulnerabilities. To make this work, engineers positioned the center of gravity far back during cruise, neutral longitudinal stability instead of the positive stability used by every other wide-body. A fuel ballast tank in the tail automatically shifted weight to maximize efficiency, but neutral stability meant the aircraft had no natural tendency to return to level flight. It would hold whatever attitude the pilot gave it. To compensate, McDonnell Douglas installed the Longitudinal Stability Augmentation System, LSAS, a computer that would artificially create the stability the airframe lacked. Early MD-11s experienced a critical problem. When pilots manually disconnected the autopilot to land the aircraft, the LSAS disengaged. Precisely when pilots needed artificial stability most, the computer let go. This issue was subsequently addressed during the aircraft's operational history, but not before it contributed to several accidents. The MD-11 entered service in 1991 with airlines desperate for fuel efficiency. FedEx, Lufthansa Cargo, KLM, They all bought in. But the crashes started almost immediately, and each one revealed the same underlying problem. July 31st, 1997, Newark International Airport. FedEx Flight 14 is landing when the captain over-controls during the flare, pushing the nose down, then yanking it back up. The aircraft bounces. The right landing gear takes 3.2 times its maximum certificated load. The wing spar fractures. Fuel tanks rupture. The NTSB ruled it pilot error, but investigators noted something significant. The captain's control inputs were well within the available control authority. The aircraft simply transferred that energy directly into the structure, with no artificial stability to absorb it. All 5 occupants survived this crash, but it revealed the aircraft's unforgiving handling characteristics. June 8, 1997, Japan Airlines Flight 706. The captain, believing the aircraft was accelerating too fast on autopilot, pulled back on the control column to slow it down, but the autopilot remained engaged. 50 pounds of back pressure built up elevator deflection. When the autopilot finally disconnected, the aircraft pitched up violently to 2.3 Gs, injuring multiple passengers and crew. The NTSB investigation revealed pilots weren't adequately informed about the autopilot's response characteristics. The flight manual had only a brief reference to disengaging the autopilot during turbulence. There was no documentation about the 2-second delay in altitude capture mode, a delay Boeing engineers acknowledged in testimony but had never communicated to operators. The NTSB concluded, the current MD-11 autopilot design, which allows for upsets to occur when pilots apply force to the flight controls, is not acceptable. March 23, 2009, Tokyo Narita Airport. FedEx Flight 80 is on final approach in gusty winds. The first officer flares late with a high sink rate. Concerned about floating past the touchdown zone, he pushes the nose down. Negative 7.7 degrees of elevator. The aircraft bounces. Then it bounces again. On the third impact, the pitch attitude reaches 8 degrees nose up. Vertical acceleration 3.06 Gs. The left wing fractures at its attachment point to the fuselage. The Japan Transport Safety Board found that the fuse pin in the landing gear support structure didn't fail as designed. The failure mode wasn't assumed during certification because engineers hadn't adequately addressed loading conditions from bounced landings with rapid pitch changes, precisely the scenario created by the aircraft's control sensitivity. Both pilots died. August 22, 1999, Hong Kong International Airport. China Airlines Flight 642 approaches in a typhoon, high crosswinds, poor visibility. The aircraft touches down hard, drifts off the runway and catches fire. 3 people die in the evacuation. Another landing accident. Another example of the MD-11's unforgiving handling characteristics when conditions weren't perfect. September 2, 1998, Swissair Flight 111. Not a landing accident, but it exposed another layer of the MD-11's design deficiencies. Arcing in the in-flight entertainment network power supply ignited insulation blankets in the cockpit attic. The material, metallized polyethylene terephthalate, had passed FAR Part 25.853B certification in vertical burn test configurations. But when rolled in close proximity and confined, as actually installed in the aircraft, the material exhibited fundamentally different combustion characteristics. It was highly flammable. The in-flight entertainment system remained powered even after the crew executed emergency load-shedding procedures. It stayed connected to AC Bus 2, meaning it remained an ignition source even after the pilots believed they'd eliminated it. The Transportation Safety Board of Canada concluded that the FAA failed in every respect to ensure the safety of the 129 people that boarded that aircraft. All 229 died when the aircraft crashed into the Atlantic Ocean off Nova Scotia. Airlines developed specialized bounce recovery training as a direct response to these accidents. Pilots were taught to maintain a 7.5-degree pitch attitude during high sink rate recovery and use thrust, not pitch, to arrest descent. But most MD-11 pilots never received that training after their initial type rating. In 1997, Boeing merged with McDonnell Douglas. It was called a reverse takeover. Harry Stonecipher, who had led McDonnell Douglas, became president and brought his cost-cutting philosophy to Boeing. He publicly criticized what he saw as Boeing's arrogant engineering culture, the very culture that had made Boeing synonymous with safety and innovation. The company decided to limit MD-11 production to freighters to avoid competition with the 767 and 777. The final passenger MD-11 was delivered in April 1998. Production ended in 2000. Boeing had little incentive to fund retrofits or design improvements to an aircraft that directly competed with its own products. This conflict of interest meant documented engineering concerns about the MD-11's design choices were never comprehensively addressed. November 4, 2025. Louisville International Airport. UPS Flight 2976 is accelerating down the runway when the left engine and pylon separate. Hydraulic lines sever. Fuel ignites. 14 people die, including all 3 crew members. The engine pylon attachment vulnerability, inherited directly from the DC-10, had never been fully redesigned. Despite 4 decades of regulatory oversight, the fundamental structural flaws of the aircraft family remained incompletely addressed. The MD-11 was an aircraft born from financial desperation, designed with compromises that prioritized efficiency over safety margins, and certified through regulatory accommodation rather than conservative engineering standards. McDonnell Douglas tried to build a safe aircraft out of a troubled legacy. They reduced the tail to save fuel. They installed computers to replace stability. They automated systems to reduce weight. But when the computers shut off during landing, when the autopilot disconnected unexpectedly, when the wiring arced and the materials burned, pilots were left flying an aircraft that punished small mistakes with structural failure. The MD-11 wasn't cursed, it was flawed by design. And decades later, that design is still killing people.